Good evening, and once again, welcome to my YouTube channel, uh, Excel Pearson International A-Level Maths by Mr. Kamotho. And today we're going to explain radian measure as a topic, and we're going to look at example 3 through example 6. And I want us to get to Pure Mathematics 1, the book displayed on your screen. The book I'm displaying, and I want us to go to page 135. And under this subtopic, we're going to discuss something to do with arc length. The arc length, the length of an arc. And we are being told that using radians, it greatly simplifies the formula for arc length. Ordinarily, we know the arc length if we have a circle of that nature, and we would want to talk about this length, and there's a theta there. We simply know that the arc length is a portion theta out of 360 to pi r. This is what we know before we learned how to use the radian measure. It's a fraction of all the 360 degrees of the whole circumference. But the length of an arc using the radian measure is explained in example 3. But before we go to example 3, let's talk about page 135 and down there. And it reads, to find the arc length L of a sector of a circle, use the formula L is equals to r theta, where r is the radius, where r is the radius of the circle, and theta is the angle in radians. Theta is angle. This is the angle at the center, of course, in radians. Angle at the center in radian form. Then let's see what is given in example 3. Let's look at example 3. And in example 3, we are told to find the length of an arc of a circle of radius 5.2 centimeters, given that the arc subtends an angle of 0.8 radians at the center of the circle. We are told to find the center of the circle O, and this is 0.8 radians, then what is L? And the radius of the circle is 5.2 centimeters. According to what is just understood, L is equals to r theta, when theta is in radians, just like this one. Then it goes without saying, we just have 5.2 times 0.8, which is straight away 4.16 centimeters. And that is just like it as far as example 3 is concerned. Can we look at example 4 in the same video, and let's explain something happening in example 4. And in example 4, we are told to find something. We're being told that an arc AB of a circle with radius 7 centimeters, an arc AB of a circle. So let's just have that sector of a circle. That is the arc we are talking about. And this is A, this is B. Has a length of 2.45 centimeters. And the radius of the circle is 7 centimeters. Find the angle AOB. This is center O, AOB, this angle. Find the angle AOB subtended by the arc at the center of the circle. This one is one of the simplest things to do, especially if you know how to work with radians, because now we know that L is equals to R theta. But what do we have? L is 2.45. It's the arc length. R is 7.0. It's the radius. Theta is what we need to know. So if we substitute all this in this formula, we are going to find that 2.45 is equals to 7 theta. That is r theta. If you divide both sides by 7, then we are going to find that theta is 2.45 over 7, or rather divided by 7, which is 0. Theta is going to be 0.35 radians, 0.35 radians. It's going to be 0.35 radians, and that is just what you've been able to do and to acquire as far as example 4 is concerned. In the same kind of argument, I think it is important also for us to explain example 5 in the same video. Let's have example 5. An arc AB of a circle with center O and radius R subtends an angle of theta radians at the center O. Yes, we have such a diagram. We are given nothing. The radius is not given, it's just R. The angle at the center is not given, it's just theta. And this is O, this is A, this is B. The arc length, let's find out if the arc length is given. The perimeter of the sector A or B, this is a sector, is P. The perimeter is P. The perimeter is P. So express R in terms of P and theta. Express R in terms of P and theta. Of course, it is important to note that the perimeter comprises of 2R. The perimeter comprises of this R plus this R, so is equals to 2R. And of course, the arc length, which is R theta. Now, we have been able to express P is equals to R theta plus 2R. And we are supposed to express R in terms of P and Q. So if we make R, if we consider that R is common at the right hand side, because it is R we are supposed to make the subject of the formula, then we're going to have P is equals to R 2 plus theta. Dividing both sides by 2 plus theta, we have 2 plus theta, 2 plus theta, and we realize that our R is P all over 2 plus theta. And that is just like it, and especially when we are able to express R in terms of P and Q. Those are examples 3, 4, and 5. But finally, in a nutshell, what we need to consider in all these and to remember is that the arc length L is given by R theta, where L is the arc length, R is the radius of the circle, and theta is the angle at the center in radians. That is the key point, in radians. Otherwise, if you are to use degrees, this is not the formula. We must go back to what we know originally, which is a bit complicated. This is much easier, and that's where we are. All right, again, go to my YouTube channel at Excel Pearson International Maths and subscribe and share widely, and let's move on. Thank you.